So here's a DPM example. This is the data matrix on a aluminum plate, and it is a dot-peened example. This is the toughest one to really evaluate, but it's a good example of the types of dot peening and 2D marking that exist in medical devices, reusable medical devices. It's a very permanent mark. We're going to put it under the window here, and we're going to use region of interest. As you can see, it is a light field mark. In other words, we've illuminated the background, and the dark foreground provides the 2D image. This one is found immediately, and it's actually a grade A, pretty good code. And like I said, this is typical of surgical instruments and things that are reusable in the medical environment. So here is another 2D code example. This one is an inkjet on a cap of a medical formula. Put it under. And again, we'll use region of interest. All right, and this code is a B grade. And as you can see over here, it's because of axial non-uniformity. You can see in the code that the axis is slightly off. So that's caused the problem. It's not a big problem. B is not too bad. And here are two of the three tablets that we're considering. You can see this one is quite small relative to the size of SCANALYST. It's maybe 2.5 times the size of the SCANALYST dome. And we've tested that unit as well as this larger unit and a third unit that isn't here on the table, but these all have the power, CPU power, to run SCANALYST, and in our tests the units seem to be adequate for speed and display area and stuff like that. So it's going to be a matter of configuring the units to appropriately meet the needs of the users. There's a lot of different varieties of these devices, and we're going to try to narrow down on one, maybe two, that we can properly configure and have an appropriate carrying pouch and things of that nature for both SCANALYST and the device. Pretty small, pretty convenient, makes it easy for people to go around and do their job. So here's another DPM part. This is a large automotive component. I guess you can see there's a laser etched two-dimensional data matrix code on this part, and we'll just put it in the view of SCANALYST here. Make it roughly in the center. Doesn't have to be perfect, but and then we'll again use region of interest to capture it and analyze it. So it found it quite fast, and it is a very good code. All the parameters are A parameters, so it's not just acceptable, it's excellent. So here is another DPM example. This one is a crankshaft, and you can see it has a data matrix mark here that is printed directly on the crankshaft, on the forged metal. and it has a lot of texture to it, as you'll see in the image, and it's printed with a dual print technique with a white background printed and then the variable data in the data matrix in the foreground. So looking at it in SCANALYST, it has, let's see, adjust the focus here a little bit. You can see all the surface problems, but anyway, the mark actually looks pretty good, so let's test it. Region of interest again, and define the area. Just close it up a little bit. So it was a pretty good mark. All parameters were good except for the fixed pattern damage. And fixed pattern damage is the L shape around the data matrix code, and it could be that it's seeing one of those dots too close to the fixed pattern, and that's causing it to degrade the fixed pattern grade. Anyway, good code, easy to grade with SCANALYST. So one of the interesting things about grading DPM is that there's a lot of variation from grade to grade or from image to image, object to object. So we think it's pretty important to maintain the image of the specific item that we graded, because if we don't do that, then there could be a lot of wasted time and effort as people try to collaborate. You know, one person will say, well, it doesn't scan, and the other one is looking at something that's perfectly good. So the image helps straighten out those discussions, and it also allows them to see what the actual problems are quicker and resolve them quicker. So in SCANALYST, every inspection has the image saved, and you can share that with your trading partners or somebody that's trying to figure out how to make things better. Very important aspect. Another item I wanted to show you is this configuration control screen. And this is important relative to a lot of things in SCANALYST, but specifically to DPM. There's controls for whether you're scanning an object that has dark marks on a light background or light marks on a dark background. And in the case of some of these technologies, you're going to want to be able to switch that around, because you may use different lighting techniques to eliminate them, and it will actually switch the same mark from a dark on light to a light on dark, just depending on where the lights come from and what type of light's being used. The second one is the spacing. In the AIM specifications, the AIM guideline, you're allowed to have variation in the dot spacing on DPM or inkjet, where the dots don't fully, aren't fully contained within the cell size, where they may be very small compared to the cell size. You can modify the dot spacing being used, and that's acceptable within the AIM specification. So you can adjust those things here on SCANALYST screens. As you can probably suspect from the screen, SCANALYST was originally designed for general barcoding use, but our first project that we tackled with the system was related to DPM, and it's very, very good on DPM. Specifically, we tackled a .peen application at the beginning, and so we grew the system from that .peen core, and like I said, this is the toughest of all barcode verification applications.